Hello, everybody. Welcome back to Math 1342. Let's finish up Chapter 2, Section 4 of Chapter 2. All right, here they are. The first question says, if we found that there is a linear correlation between the concentration of carbon dioxide in our atmosphere and the global temperatures, does that indicate that changes in the concentration of carbon dioxide cause changes in global temperature? Remember, there's a little saying we said in that chapter is that causation does not imply a change. Okay, so you can't say that's because there's a correlation does not imply causation. Just because there's a correlation or something doesn't mean that one thing causes an effect of it. It's just a recording that this one event, there is a relationship to it. So this one here, the answer is no. What is a scatter plot? How does it help us? Scatter plot's not a formula, so that's not it. It's not a table, it's a graph, so it's got to be either B or D. The graph of paired XY is it qualitative or quantitative? It's quantitative. Scatter plot deals with quantitative numbers because they have to be digits, they have to be integers, have to be numbers that we deal with. So answer is D. All right, number 3. Construct a scatter diagram using the data table to the right. The data is from a study comparing the amount of tar and carbon monoxide in cigarettes. Use the tar for the horizontal, so the tar is the x-axis and the carbon monoxide is the y-axis. So that's the horizontal. This one goes left and right. This one goes up and down. Determine whether there appears to be a relationship between the cigarette and tar. Yes, we could go through and actually create our own. So at 16, we have 4, 8, 12, 16, 20. And going up, we get 4, 8, 12, 16, 20. So the first one, at 16, there's 15. At 11, right about there, there's 13. At 1, there's 1. At 13, there's 14. At 5, there's 7. I mean, just for these alone, we know it can't be A because that's going down. It can't be B because these are all scattered everywhere. And we notice at 1, 1, there has to be a point at 1, 1. There's no point here, so that doesn't, there's no point there. So it's got to be either B or D, or C or D. Okay, it's the next one. Let's look at the next smallest one. At 2, it's 3. So that one's closer to 4. This one here is 2 and 3. So I'm saying this one's going to be D. This information is D because just of these first 2, the second dot looks wrong. Now, is there a relationship between the cigarettes and carbon monoxide? No, that's not it. There is because it looks like it's going up. So the more tar you have, the more carbon monoxide you get. Yes, the amount of tar, as tar increases, so as tar increases, the carbon monoxide decreases. No, that goes up. So it's got to be C. As tar increases, so does carbon monoxide. So it's D and C. All right, and number 4. Same thing here. Good. Here's our data set. This is our X and this is our Y. Oops. Okay, so let's look at the smallest data point we have. This 2,700. It's at 36. So this is 25, 30, 35, 40, 45. So at 27, so right here, we go up to 36. That's good. 27 goes 36. This one's wrong because at 27 it's only 22. 27, 20, 25, 30, 35. So this is, so it can't be C or D. So that's the next one. The 2,900 is 34. At 29, right here, it's 34, just under that one. 29. Yeah, it can't be that one. So it's got to have to be A. Let's just look at the dots. So the first one's at 36. Next one's at 34. So it's pretty close to this 35 right here. Is there a linear correlation between weight and mileage? Yes. As the weight increases, the miles decrease. Increase, that's wrong. No, there is a correlation. So as weight increases, mileage decreases, so it's got to be D. And there goes that one. All right, good luck, everybody.